Okay, jalan.
Okay, Assalamualaikum and good evening to Dr. Adnan and my beloved friends. Um, we will present to you slide about high efficiency of hybrid cycle engine. Before I start this presentation, I would like to to you uh, my group members. The first is me Muhammad Munif Hanif bin Marahim. The second Atif Zafran bin Zai Azman. The third Muhammad Umay Fitri bin Nur Uris. And the last is Muhammad Ahmad Adli Khairfan bin Aizatul Khair. Okay. We go through to introduction of HEHC. The background of introduction is high efficiency hybrid cycle engine to fuel efficiency and power density are two critical parameters for specifying an internal combustion engine. The second, in general, both numbers have been increasing over time since the earliest days of the engine development. But now, as oil price are skyrocketing because of war, because of politics in the world, uh, there is a more pricing need to build a very efficient engine. The car maker would must build a efficiency engine to vehicle. And the problem statement is the first is the problem statement for HEHC X engine technologies to develop a more efficient and eco-friendly powertrain for vehicle. Second, this can be achieved by combining tradition a traditional internal combustion engine like ISE, conventional engine, with an electric motor and battery system, creating a hybrid powertrain. The third is the goal of HEHC is to improve fuel economy and reduce emission. Reduce emission is the first goal in HEHC project, while maintaining or even improving the performance of vehicle. Okay, the objective of HEHC is the HEHC, the efficiency hybrid cycle, is a type of internal combustion engine that combines the advantage of the gasoline and diesel engine to improve overall efficiency and reduce the emission to ambient or environment. And the scope is the high efficiency hybrid cycle engine technology is a type of engine design that aims to increase the efficiency of internal combustion engine by using a combination of a conventional combustion engine and the electric motor. This HEHC technology can improve the fuel economy and reduce emission compared to traditional internal combustion engine ICE. The X engine technology is the specific design of HEHC by the company X engine. Next, I would like to pass significance of study to Umay Fitri.
Okay, thank you, Manik. The significance of study. First, the high efficiency hybrid cycle. HEHC as engine technology is a novel propu- propulsion system that combines the best feature of both gas turbine and piston engines to create a more efficient and environmentally friendly power generation system. The second is the study of this technology is important because it has the potential to greatly reduce the environmental impact of this industry and improve their overall performance and efficiency. Okay, next slide. For Atif Zafran.
Uh, I continue my working principle of component. The two main components of a high efficiency hybrid cycle engine are the internal combustion engine (ICE) and the electric motor. The ICE is responsible for providing the power to propel the vehicle, while the electric motor provides additional power when needed, such as during acceleration of uphill climb. The motor is also used to supplement the ice during deceleration and braking, allowing for improved fuel economy. Additionally, the electric motor can be used to capture braking energy and store it in a battery for later use. Other components of a hybrid cycle engine include the battery, the control unit, and other electronics. The high-efficiency hybrid cycle engine work by combine the benefit of both of internal combustion engine and an electric motor. The engine uses a combination of a four-stroke internal combustion engine and electric motor to produce power. The internal combustion engine is used to produce high torque at low revolution per minute (RPM), while the electric motor is used to produce high power and high RPMs. The two types of power source are combined in a way that maximize the overall efficiency of the engine. The electric motor is used to augment the power of the internal combustion engine we need, while the internal combustion engine is used to supplement the electric motor when needed. In most cases, the electric motor is used to supply the majority of the power, while the internal combustion engine is used to provide a boost when additional power is needed. The hybrid combination result is an engine that is more efficient than a traditional internal combustion engine. Next slide. ICE. Working principle of an internal combustion engine is the four-stroke cycle. The cycle consists of four distinct phases: intake, compression, combustion, and exhaust. During the intake phase, air and fuel are drawn into the cylinder. During the compression phase, the fuel mixed in compressed. During the combustion phase, a spark ignites, the fuel are mixed, causing combustion. During the exhaust phase, the exhaust gas are released from the cylinder. The cycle repeats as long as the engine is running. Electric motor. An electric motor converts electrical energy into mechanical energy. It works by using electromagnetism to create a rotate magnetic field in the motor, which causes the motor armature or rotor or to spin. This is accomplished by a series of wire coils that are connected to the armature and energized with alternating currents, electric. As the current passes through the coil, it creates a magnetic field and it interacts with the armature and causes it to spin. The electric motor is used to augment the power of the internal combustion engine with need, while the internal combustion engine is used to supplement the electric motor with need. In most cases, the electric motor is used to supply the majority of the power, while the internal combustion engine is used to provide a boost when additional power is needed. This hybrid combination results in an engine that is more efficient than in traditional internal combustion engine. The next slide.
The next
Atif.
for this part is advantages of HEHC. The first, reduce emission. Hybrid cycles reduce emission as they use less fuel, which means lower greenhouse gas emissions. Low maintenance. Hybrid cycles require less maintenance than traditional cars as they have fewer moving parts. Reduce noise pollution. Hybrid cycles produce less noise than traditional cars, reducing the volume of noise pollution. And the last one is cheaper to run. Hybrid cycles tend to be cheaper to run than traditional cars as they use less and require less maintenance. And for the advantages of HEHC is the first one, hybrid cycles engine are more expensive than traditional engines. The second is hybrid cycles engines are complex and require specialized training for maintenance and repair. And the next is hybrid cycles engine have a limited range and require frequent charging. And the last one is hybrid cycles engine may not be as durable as traditional engines. The next slide I will pass to Umair Fitri.
Okay, thank you, Atif. This is the analysis of HEHC system. Deviation from the air standard cycle are calculated as follows. The value corresponding to each point on the PV diagram provided in table 1. Okay, this is the analysis of HEHC. Next slide. The conclusion. We present a rotary engine design capable of implementing the high efficiency hybrid cycle in this paper. This engine is expected to have superior volumetric efficiency as well as efficiency across a wide range of loads. The engine is currently being prototyped and the working compressor is already in place. Okay, that's all for the slide. Thank you, sir.
Thank you, sir.
Thank you, sir.